Hello, in this video we are going to find the domain of the function, and we're going to use interval notation to describe the domain. I am going to find the domain of this function f of x equals 3 minus radical 6 minus 2x. As an aside, I am going to look at y equals the square root of x. And for that reason, maybe I will switch over to graph paper. So I'm going to look at y equals the square root of x and just check out that function. And the reason I went to graph paper is because I want to do a little tiny sketch with that. So this is an elementary function where we can plot points. You can do it sort of in your head. Square root of 0 is 0, square root of 1 is 1, square root of 4 is 2. And so that gives these points here. And I'm going to just put that together there. So that is y equals radical x. And one of the reasons I wanted to sketch that is so that we can visualize what we see is that the domain is all x greater than 0. Which in interval notation, sorry, that's not even right, greater or equal to 0. Because you can have the square root of 0, 0. So in interval notation, I use the square bracket, 0, comma, infinity. Okay, so, I mean, that's the picture, and then think about square root of negative 1, that's not a real number. Square root of negative 4, not a real number. So looking at real numbers, we can only, the domain is x greater or equal to 0. That's the values that for x which I can put in, any non-negative real number. So for this guy over here, now that I'm going to do the solution, I'm going to focus on that radical. And for this piece over here, this radical, we require for the domain that 6 minus 2x is greater or equal to 0. So what is underneath the radical? The input to the radical cannot be negative. It has to be greater or equal to 0. So what am I going to do? I could subtract 6 from both sides. That's going to make negative 2x greater or equal to negative 6. It might have been easier if I just added 2x to both sides. So because now what I'm going to do is I'm going to divide, and I need to remember something, that when I divide by a negative, I change the direction of the inequality. When dividing by or multiplying by a negative number, we flip the direction of the inequality. I could have avoided that by adding 2x to both sides, and then I wouldn't have had to deal with that. I sort of wanted to make a point to remind everybody that's what we do. Okay, so of course if I leave out all the little comments, it would go faster. But we change the direction of the inequality, and we get that x is less than or equal to 3. And that is the domain. The domain let me write it this way. The domain of f of x equals 3 minus radical 6 minus 2x is the set x such that, all x, such that x is less than or equal to 3. But we're supposed to write our answer in interval notation. Just want to write a little neater. Now, to help me do the interval notation, I mean, we can just get the answer more quickly, but I'm trying to explain, but by overdoing it, sometimes it makes it more complicated. But x less than or equal to 3, when I graph it, looks like this. I'm going to shade everything to the left of 3. Okay, I shade everything to the left of 3, including I'm going to shade 3. So maybe I should just use a different color there. This is what that looks like. So when I write this in interval notation, I'm going to write the right endpoint is 3. And because it includes 3, I put this square bracket. There is no endpoint on the left. What we write is we write negative infinity. And when we write negative infinity, we always write the round bracket. And so this is the domain. That's the final answer. That is the domain. So I can write domain of f equals this. That's actually our final answer. All right, so let me zoom out on the whole thing. I wrote more than necessary. I wrote little asides and so forth, things like that made it appear as if doing one of these problems will take a lot of space. But that was because I wanted to be thorough and explain. But we have an aside for radical x, but we look at 6 minus 2x under the radical. That has to be greater than or equal to 0. It can't be negative. And then we solve, and there's our answer. Okay, that finishes it up. Goodbye.